Okay, Louisa, we're back, picking up with number 35. So, given that f of negative 3 equals 0, what binomial must be a factor of this polynomial? Since this tells you the remainder, that means that x plus 3 must be a factor. Now, given your answer to part A, algebraically determined, so it's another long division problem. Long division everywhere, probably a part 2 or 3 question on the Regents exam. That's why we spend so much time doing it. All right, so there's your x cubed. Put the x squared up here, plus 3x squared. Change the sign, negative 4x squared minus 44x. I need a negative 4x squared. Therefore, this is a minus 4x. That becomes a negative 12x. Change the sign, those cancel. I have a negative 32x, bring down the minus 96. So then I need a negative 32x, so minus 32. Negative 32 times the 3 gives you a negative 96, which gives me a remainder of 0. So that means that I have determined the other two factors. I have x squared minus 4x minus 32. They equal 0. Factors of 32 that give me 4 are negative 8, positive 4. So x equals 8, x equals negative 4. So determine the other two factors. So the other two factors are right here. Okay? They wanted the two factors, you could have stopped there. They don't want the zeros. Okay, now solving for the following equations. Common denominator, solving. There's your x minus 2. This factors to x minus 2. See how that works? LCD is x minus 2. So multiply everything by the x minus 2. The x cancels, so I have 5x minus 2 plus x plus 1. And then the x minus 2 cancels, and there's an x. Equals, this all cancels, so I have an x plus 4. See how it's an equation? So you can get rid of the denominators. So this is a 5x minus 10 plus x squared plus x equals x plus 4. Now combine the like terms, get everything on one side because you have an x squared. So let's put it in descending order. You have an x squared, so here I have, look, 6x minus 1 is plus 5x. Bring the 4 over, minus 14 equals 0. X plus 7, x minus 2 equals 0, x equals negative 7, x equals 2. Okay? Now, what I did not do in the beginning was identify where it's undefined. So x cannot be 0, x cannot be 2, because that's here and here. So therefore, this x equals 2 is an extraneous root. That is gone. So the only solution is x equals negative 7. Inequalities, very similar. You cross multiply if you have a single fraction on the left and a single fraction on the right. And just make this, make sure you make that equal to. Make sure that you take into consideration where it is undefined. So this is a critical value, remember, at x equals negative 3. So right here at negative 3, it's an open circle because it's a critical value. And then when we cross multiply, I have a 3x plus 9 equals 5x plus 1. So bring the 3x over, bring the 1 over, x is 4. So we have 4, which will be colored in. Okay, colored in circle. Better than mine. And then remember you have your test areas. So you put in your calculator the original equation such that I would test, like negative 6, test the 0, test 7. Remember, true, false, true. Okay, so if it works, there's your true, there's your false, there's your true. And it says to graph it on the number line. So I just show it like this. So I can see that it's very clear where your solution is. If you just draw a line on the axis, I can't really see it. All right, so if you go above it a little bit, That makes it very clear. And that just says graph. It doesn't say that you have to represent it. If you wanted to, it would be x equals -3, or x is greater than or equal to 5. Oh, 4, sorry. Okay. Couple more, and that's it. So same thing, the inequality here, undefined at x equals -3. So here's your -3. It's a less than or equal to. So all you have to do when you cross multiply, this is going to be gone. So we have x squared plus 5x minus 50 equals 0. Factors of 50 that give me 5. You got x and x plus 10 minus 5. So x equals -10, x equals 5. So -10, color it in, 5, color it in. Now you have, all the way to the original equation, you have 1, 2, 3, 4 areas to test. So make sure you go back to the original equation. So in zone 1, like a -12 put in, that is going to work. It's going to be true. Between -10 and -3, it doesn't work. There's your false. And then from 3 to 5, it works. That's a true. And then from 5 on, it is false. Doesn't work when you do the such that. So it does say solve the inequality, graph its solution. So we have like this, and then like that. So if you wanted to represent it, it'd be x is less than or equal to -10. And you can also have -3 is less than x, which is less than or equal to 5. So you got to be very careful of your inequality symbols. All right, 39 you're not really going to see, but we'll just talk about it since I have some time left. Square root, okay, so we're starting with this. What property justifies that? And what we're doing there is squaring, which is a multiplicative property because you're multiplying. Which of the two root solutions are extraneous? So they give you the solution, you go back and plug them back in. So we plug them back into the original equation, and -3 works. 3 is the extraneous root. Okay, there's only one correct solution. Why does an extraneous root get introduced? And that's because you squared both sides. When you squared both sides, you were unsure if they were going to want the positive or negative value. So that's why you had to go and test them both. All right, and I think that's it. So this is due Wednesday, and your benchmark is Wednesday, Thursday. All right, see ya.